let's go to gltext.h and get started on that portion. So just like GL draw, we are going to grab all that stuff there and drop that into here. And I want to say thank you to C5, who's a very old member of the forum, who he actually showed me how to do this a long time ago. So struct vec3, so thanks to him. Float x, y, z, and we need to end that. Not like that, please. Namespace, GL. So we're going to be defining inside the same namespace as GL draw. We are going to be just doing it in another file, which is kind of neat. And inside here, we're going to have a class called font. And in it, we are just going to do public. Essentially, this is just a struct. bbuilt equals false. Unsigned int base. HDC equals null pointer. You can tell the different coding style here. I wrote this at a different time. Then I wrote the rest of the code here. So int width, void build, and it's going to take a height, and void print float x, float y, constant, unsigned char, color 3, constant char, pointer, format, ... just like printf, right? And then we're going to do a vec3 center text, and it's going to take float x, float y, float width, float height, float text width, float text height, and we need to put an n in here. vec3, yeah. And then we have another center text function, which is going to return a float. It's float center text, float x, float width, float text width. We have build, and then we just need to define these over in the source file. And we're going to do GL scope on all 3 of those. These are all functions just for our font. So in our constructor, which we're actually going to build with it, is HDC equals WGL get current DC. Base equals GL gen lists 96. And hfont, hfont equals hfont, create font A. Break, what are you doing here, dude? So we're going to do minus height, 0, 0, 0, this is an interesting function call, fw medium, false, 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 ANSI, char set, out, tt, precision, clip, default, precision, the big ass function call, clip default precision, proof quality, ff don't care, default pitch. And the last thing is the actual font name, which is going to be Consolas. I think this is the biggest function I've ever called. This is crazy. So that should be good. So all this is doing is it's creating a font using the ANSI version. The height is negative 0, 0, 0. And all these other things are just going to define, there's so many different ways you can use a font, right? These all just defining the font and what types of characters it's going to be able to use and how it's going to look like on the screen. Now, we are using Consolas, which is a cool looking little font, especially for GameHack. But the most important thing here is it's a monospaced font, which means that the width is always the same on every character. So when you are trying to make everything look all nice together and get everything aligned just perfectly, you don't need to get the the width of every single character in the string, because you know, like for instance, we're going to use the font size 15 here. On Monospice Consolas, every character is 9 width. So in order to get the width, the physical length of the string, we just take string length, which is the number of characters, and we multiply it by the number 9, and now we have the width that the string is going to be when it's on the screen. Why isn't WGL get current DC? Uppercase C. And so, yeah, all this stuff, it's all in the OpenGL documentation. If you guys have gotten this far in the series of tutorials, you should know, you know, you're going to have to learn all this shit on your own. I can't explain every single word to you, you know? The tutorials will be 10 hours long. So anyways, we have our old font, which we're going to set. This is just like the proper way to do it. H-font, select object, HDC, H-font. WGL use font bitmaps, HDC 3296 base. I think that just defines which bitmaps in the font we're going to be selecting, and we're going to be storing them into base or whatever. All right, select object HDC H old font, delete object H font, B built equals true. If you're kind of familiar with this, it's kind of similar to like drawing a window with Windows 32 API and drawing stuff on it in GDI. But anyways, we're going to get the current device context, and we're going to store it in the handle to device context. We're going to generate a GL list of size 96, and we are going to create the font using our Consolas monospace font in the exact way that we're defining it. And then we're going to select that object, and we're going to select the current font that's in the HDC. We're going to select our font and associate it with the device context, and the old font we're going to store in case we need to restore it later. So WGL use font bitmaps, it's basically saying, right, we've got our list that we've generated called base, and we've associated with our device context, and 32 to 96, that defines the beginning and the ending of the glyph list of characters that we want in our font that we're going to be using. Okay, so like in your font file on your disk or whatever, it's got like however many characters there are, numbers, special characters, all that stuff. We only want 32 through 96. That basically includes like all the letters, all the numbers, and all the basic special characters that you might use, and not any other stuff that we don't need. So we just need that set of characters between 32 and 96. I believe they're called glyphs. Everything's all set up. Our list is generated, our font, etc. We're going to do select object, and we're now going to select our old font and make that our main font for our current device context, and we're going to delete our font. We've already set everything up with the font that we need, and we've put it into base. Okay, and basically base, it's going to be a collection of bitmap glyphs that we're going to anytime we print, it's basically going to parse that list and grab the correct one and display it onto the screen. When it's all done, we're going to set be built to true, because anytime the device context changes, we need to rebuild the font. So GL font print. We're going to do GL color 3UB, color 0, color 1, color 2. Oh boy. Okay. GL raster position 2F, X comma Y, char text 100. So we're hard coding that, so you can't, if it's bigger, it's not going to work. VA list args, VA start args format, VS print F underscore S, that is a secure version, text 100 format args, and VA end args. And then we have GL push attribute, GL list bit, GL list base, base minus 32, GL call lists, string length, text, GL unsigned byte text, and then GL pop attrib. I believe that's GL push a trib. Okay, so we're going to pass in a x and y coordinate where we want to start drawing our string, the color of the string. This is our format string, which defines the format of what we're going to print. And then this last part is going to be just like printf is going to be the actual string that we're printing itself, usually just one. And we're going to set the color to the color we chose. We're going to set the position where we're going to start drawing by using raster position. All raster means is where you're going to start drawing, basically. We have a char of 100 size, so that's hard-coded, so you can't do a string larger in size than that. We have a variable argument list called args, and basically what VA star at ends does is it's basically like a loop. Like, okay, so for each character in that string, for each string we're going to apply the formatting, okay, by using printfs. So each one of the variable arguments up here is going to be passed into this, and it'll be stored into text. And then we are going to push the GL list bit attribute onto the GL attribute stack. And then at the end, we're going to pop it back off, right? Because we're going to be messing with that bit right here. We're going to set the list base to base minus 32. And then we're going to call GL call lists, which is going to go through each char in text of length size of the string length of the size of the text, and it's going to call each one using the GL unsigned byte type. And then we pop the attributes. I don't want to explain every line of this and how it works and what it does. You just, at this point in your game hacking career, you have to read documentation. You have to spend hours and days reading it and learning how it all works. Next up, we have GL center text. And so this is going to be vec3 text, and we're going to do text.x equals x plus width minus text width divided by 2. Text.y equals y plus text height, and return text. So this is just a centering text function. So the purpose of these functions is we're going to give it a location, like kind of like a rectangle, and we're going to center the text based around that rectangle. The x and y is going to be the top left location of the rectangle, and then the width and the height is the width and the height of the rectangle. Text width is going to be our text string, how wide is it as compared to the width of the box, the rectangle. Text height is going to be the height of the character in the string. In this case, it is 15, right? So all this little algorithm does is it takes, if I put in this little box here, then we're going to tell it to draw in the center right here so it looks nice. What this one does is it centers it on the x and y axis. This only centers it on just the x axis. So this part is going to be if width is greater than text width, float difference equals width minus text width, return x plus difference divided by 2. Excellent spelling as always. Or if the text width is greater than the width of the rectangle, we're going to do float difference equals text width minus width, return x minus difference divided by 2. And so basically, if our string is wider than this box, we are going to make it center over the box in another way so that each edge of the string overlaps the left and right side of the box in the same distance. So it's just going to center it, just looking a little bit differently. All right, so now we have to go to DLL main. This whole thing is getting a little bit messy here just because we have a lot of stuff. But just to make this video quick and easy, we're just going to dump it all in here. Just to make this make a little more sense, we're going to change this. Instead of a pointer to the original swap buffers, we're going to call it the WGL Swap Buffers gateway, because that's actually what it is. If we go down to the bottom of our hook, we're not calling the original function, we're calling the swap buffers gateway. So that just will make it make a little more sense while we're coding here. So first thing we need to do, we need to create a GL font object called GL font. And we're going to do constant int font height equals 15, constant int font width equals 9. Now we only have to define font height as being 15, and then because we're using Consolas, we know that that font width is always 9. That's just how it works. Oh, you know what else we need to do? We need to include GL draw and include GL font or text. Yes. Constant char pointer example equals ESP box. This is just the text we're going to draw. Constant char pointer example 2 equals I'm inside fam. Basically at the end, after we do all of our coding hacking stuff, at the very bottom we want to draw. You always want to draw after you do everything else, right? That should be the last thing you do. So we're going to call this function called draw, and we're just going to define that up here. So void draw, we need to get the device context. So HDC current HDC equals WGL get current DC, and then we're going to do if GL font.be built or current HDC does not equal a GL font.hdc GL font.build, and we're going to pass in font height. We get the current DC every frame, and if the font has not been built, we need to build it. So that's just initializing our first build. You need to do this in the context of the current HDC, or it's not going to work. If you do this outside of a SwapBuffers hook, I do not believe this works at all, if I recall correctly. The second part is, if your current HDC doesn't match the old one that you have stored in your font, then that means the device context has changed. Let's say maybe you're in a game, and when you go from single player to multiplayer or something, it changes the device context or something like that. In that case, your font only applied to the previous one, not to the current one. So if that ever changes, we need to build again. That doesn't happen in most games, but I've had it happen in a couple. So now we need to set up ortho so that we can get that orthographic projection matrix, and we're going to GL restore GL at the end. And in between these things, we are going to draw. So we're going to do GL draw outline 300, 300, 200, 200, 2.0 F RGB red, and float text point y equals GL font dot center text 300, 200 string length example times font width. We have float text point x. Hey, x is up there, asshole. Text point y equals 300 minus font height divided by 2. GL font dot print text point x, comma text point y, RGB green, percent %s example vec3 inside text point equals GL font dot center text 300, 300 plus 100, 200, 200 string length example 2. Multiply that by font width, and then we're going to pass in font underscore height. And then we're going to do GL font dot print inside text point dot x inside text point dot y, RGB green, percent %s example 2. Then GL restore GL. We set up orthographic projection matrix. We're going to draw an outline, okay? We're going to pass in 300 as the x and the y coordinate, so it'll be kind of near the middle of the frame. These are just random numbers, by the way, nothing special. And then the width and the height of the box is going to be 200, so this is going to be a square. The width of the line is going to be 2, and we're going to draw it in red. Now, we want to center our text on that position basically above the box. So we're going to pass into center text function. So we're going to put the x at 300, and then the width of the box is 200. And then we're going to take the length of the string and multiply font width to get the ultimate width of the entire string on the screen. The text y point is going to be 300 minus font height divided by 2. Now remember, the y grows as you go down. So in order to get it above the box, we need to subtract. So we're going to subtract font height divided by 2. That's kind of be like our buffer. So our buffer above the box to where we draw is going to be font height divided by 2. Just works out to look nice that way. So then we're going to call GL print. We're going to pass in the text point. After we call center text, right, it's going to give us this position right here to start drawing now. And we are going to pass in the X and the Y point, green, again, the format string, and the actual text that we're going to be drawing. And then we're going to do the same thing here. The difference is we want to center the text inside of the box. So the X and the Y, where the box's top left coordinate is 300 and 300, right? And then we want to go into the middle of the box. So the box has 200 height, so half of that is 100. So we're going to go to the middle of the box by supplying this as the Y value, the width of the string, and then the height of the string. We don't need to multiply the height of the string by anything because it's a horizontal string, not a vertical one, right? And then we're going to call print X, Y, green, same thing we did before, and then we're going to restore. Yes, we want to convert this to our new hook class too. So to do that, let's do, we're going to create a hook object, and it's going to be called SwapBuffers hook, and we're going to do get proc address, get module handle, L macro OpenGL32.dll, parentheses, and then WGL Swap Buffers, again parentheses, and then we have HK WGL Swap Buffers, and then the address of WGL Swap Buffers. And then our length is 5, and then we are good. And there's definitely a typo here. We need to cast here. So we're going to cast these to a byte pointer because that's what our function takes. We also need to cast this. I know what we need to do. We just need to do this. Like we also need to cast this. We are actually going to do, we've changed it to the gateway. WGL Swap Buffers gateway, grab that. And after we create the hook, we're going to do Swap Buffers hook.enable. You could just do that in your constructor too, if you wanted to. And then we're going to do a sleep. This is just like a test for the video. And then we're going to do swap buffers hook.disable. So we're just going to draw for 10 seconds and then we're going to unhook. We no longer need this because everything we're doing in here, we're doing right in our constructor here. So we'll get rid of that. This is just another example. We can actually do it another way as well. We can, because remember when we did our hook constructor, we have one that takes the export function method. So we're actually going to use that because it's cooler. Swap buffers hook. And we're going to pass in a string. WGL swap buffers OpenGL32.dll. And then the rest of the arguments are the same. So instead of using this more unwieldy, annoying version, we'll use this nice, beautiful version. And it compiled. Okay, so let's see if it works. All right, we've got our injector loaded up. Let's inject it. All right, well, we got a half a box, so we screwed up something here. This last vertice needs to be like that. All right, I fixed my little mistake. Let's re-inject, and now it works perfectly. And after a few seconds, it unhooked itself after the 10 seconds, and now our box goes away. Perfection. Okay, so this is cool. This all worked. The last thing to note here is free library and exit thread. That was in our old hack. And now let's see if we can get that to work. So after we unhook, can we free library exit thread? And then can we re-inject? That's the big question here, right? So H module and the exit code, I think, can just be 0. All right, so let's inject the new one. And we are good. 10 seconds should go by. And it should be uninjected now. And now I should be able to inject again. Yes, it works. Okay, cool. I guess the next thing we have to do is make an ESP, huh? I really hope you enjoyed this video. Again, guidedhacking.com/donate, patreon.com/guidedhacking. Please support us so that we can continue to make videos, and peace out.